Have you ever wondered what exactly an object is in programming? Well, in the realm of coding, an object is an instance of a class. Think of it as a concrete realization of a blueprint that's been defined by a class. Now let's delve a little deeper. An object encapsulates data and behavior related to a specific entity or concept. It's like a neatly packed box that holds everything you need to know about a particular entity. Let's take a person class as an example. This class might have attributes or properties such as a name, age, and address. These attributes represent the state of the object, in this case, the specifics about a person. But objects aren't static, they're dynamic entities that can do things. These actions are defined by methods. For instance, the person class might have methods like say _hello, eat, or sleep. These methods define the behaviors or actions related to a person. Objects encapsulate or bundle together these attributes and methods into a single unit. This encapsulation provides a clear interface for interaction, while keeping the internal details hidden away from the outside world. It's like a well-organized toolbox. Everything you need is there, but you only pull out the tools when you need them. The process of creating an object from a class is called instantiation. So if person is the class, creating a specific person, like person1, involves instantiating an object. You might write something like person1 equals sign person in your code. Each object has a unique identity, state, and behavior. The identity is usually represented by a memory address or a unique identifier for the object. The state is represented by the object's attributes, and the behavior is defined by its methods. So, in essence, an object is a bundle of attributes and methods that define a specific entity. It's a powerful concept that's fundamental to object-oriented programming, and it's the bedrock of countless applications and systems. Now, let's delve into the concept of encapsulation. This principle, a cornerstone of object-oriented programming, is all about bundling data and methods that operate on that data within a single unit, often referred to as a class. Think of a class as a blueprint. It outlines what an object of this class should look like and how it should behave. Now, encapsulation takes this blueprint and wraps it up neatly, creating a package that contains the object's attributes and methods. This bundling is like placing a cloak around the object, simultaneously protecting its inner details and providing a clear interface for interaction. Imagine you're interacting with a vending machine. You don't need to know how it internally sorts coins, checks their validity, or dispenses the right product. All you need to know is how to input coins and make a selection. The vending machine encapsulates its internal mechanisms and exposes only the necessary interactions, like the coin slot and the selection buttons. In the realm of programming, encapsulation works in a similar way. It restricts access to the internal details of an object, allowing interaction only through a defined set of methods. This is achieved using access modifiers, which control the visibility of an object's attributes and methods. There are 3 types of access modifiers: public, private, and protected. Public members are accessible from outside the class, private members are accessible only within the class, and protected members are accessible within the class and its subclasses. Encapsulation also facilitates data hiding. By making attributes private, direct modification from outside the class is prevented. Controlled access is then provided through methods, often referred to as getters and setters. This way, the object's internal state is shielded, ensuring that changes to its attributes are made in a controlled and predictable manner. Encapsulation, therefore, provides a protective shield that prevents the data from being accessed directly. It's like a barrier that keeps the object's internal workings safe from outside interference, ensuring that the object remains in control of its own data. Ever wondered how these objects come into existence? Well, it's all thanks to a process known as instantiation. This is the act of creating an object from a class, similar to how a blueprint is used to build a house. When we instantiate, we're essentially breathing life into a class. Let's take an example. If we have a class named person, to create a specific person, say person1, we instantiate an object like so, person1 equals new person. And voila, we've just created an object. These objects are not just empty shells though, they come with their own unique identity. This identity is typically represented by a memory address or a unique identifier. Much like how every human has a unique fingerprint, every object has a unique identity. This allows us to distinguish between different objects, even if they're of the same class. Imagine having two objects of the person class, person 1 and a person 2. Even though they are instances of the same class, they are distinct entities, each with their own identity. If person 1 has the name Alice and person 2 has the name Bob, changing the name of person 1 to Eve won't affect person 2. Bob will still be Bob, unaffected by Alice's identity crisis. In this way, every object is a unique individual, carrying its own set of attributes and behaviors. This identity is crucial as it allows us to interact with objects independently, ensuring that changes to one object don't inadvertently affect another. But remember, just as you wouldn't use a blueprint to live in a house, you don't interact with the class directly. Instead, you interact with the objects, the concrete realizations of the class. Each object is a tangible manifestation of the class, complete with its own identity, state, and behavior. Instantiation, therefore, breathes life into a class, creating an object with its own unique identity. And it's this process of instantiation and the concept of object identity that make object-oriented programming such a powerful and flexible approach to coding. Scene script. Let's dig deeper into encapsulation. One of the key ingredients that make encapsulation work are access modifiers. Access modifiers like public, private, and protected control the visibility of attributes and methods within a class. Public members are like an open book, accessible from anywhere outside the class. Private members, on the other hand, are like a secret diary, accessible only within the class itself. And then we have protected members, accessible within the class and its subclasses, much like a shared family secret. But why do we need to control visibility? Why not make everything public? Well, imagine if everyone had access to your personal information. It would be a privacy nightmare, wouldn't it? The same logic applies to our classes and objects. This brings us to the concept of data hiding. By making attributes private and providing controlled access through methods, often known as getters and setters, encapsulation facilitates data hiding. It's like having a security guard at the entrance of a private event, checking the guest list before letting anyone in. This prevents direct modification of object attributes from outside the class, enhancing the security of our data. Now, let's talk about information hiding. While it may sound similar to data hiding, it's a slightly different concept. Information hiding involves hiding the unnecessary implementation details from external entities. It's like going to a magic show. You enjoy the tricks without knowing how they're done. This reduces complexity and improves modularity. Plus, it allows for changes in the implementation without affecting the external interface. So, encapsulation is not just about bundling data and methods together. It's also about controlling their visibility, hiding data, and concealing information. It's like a protective shell that guards the inner workings of our objects, keeping them safe from unwanted access and unnecessary complexity. Encapsulation, therefore, is a powerful tool that helps ensure data security and maintainability. Ever thought about the benefits of encapsulation? Let's dive right in. To begin with, encapsulation enhances security. By restricting direct access to an object's attributes, we can ensure that data isn't tampered with unexpectedly. Think of it as a vault, where your precious data is stored. You wouldn't want just anyone to have access to the vault, would you? Similarly, in programming, encapsulation provides a secure way to protect data from unwanted access. But it's not just about security. The power of encapsulation is also seen in the improved modularity it brings to our code. When data and methods are bundled together into a single unit, it becomes easier to maintain and understand the code. Each object becomes a self-contained unit of functionality, like a perfectly packaged gift box. This makes our code cleaner and more organized, which in turn makes it easier to work with. Encapsulation also gives us better control over data access. Using getters and setters, we can control how the data within an object is accessed and modified. This means we can put checks in place to ensure that only valid data is stored in our object's attributes. It's like having a gatekeeper who ensures that only the right kind of data gets in and out of our object. Lastly, encapsulation allows for changes in implementation without affecting the external interface. This means that the internal workings of an object can be modified without disrupting the parts of your program that use the object. It's like changing the engine of a car. The driver doesn't need to know how the engine works. They just need to know how to drive. Similarly, with encapsulation, we can change how an object works internally without affecting how it's used. So, Encapsulation not only bundles data and methods into a single unit, but also brings along a host of benefits that make programming efficient and secure.